Good morning, everyone. Today, we will be presenting our project for the Tech Symposium, which is called the Rain Sensavior. Our team, Lucky 13, is comprised of Thomas Ramirez, Elizabeth Rosette, and me, Khaled Nafa. My role in this project is the main developer. I am in charge of developing the circuitry and troubleshooting any issues faced during the development of this project. Now, I'll pass it on to Elizabeth.
Thank you, DJ. Hello, everyone. My name is Elizabeth Rosette. My role in this project is lead documenter. I'm in charge of documenting any changes made to our project, and I also developed the code that was needed. And now here's Thomas with his introduction.
Hello, I'm Thomas Ramirez, and I'm the project manager for my team. This position requires me to make sure my group members are communicating efficiently, meeting goals to complete tasks, and working in areas that need help. Some of my technical strengths are project planning, calculations, and quality control. So some background on our project is that there are no similar products such as our own. We wanted to try and make a unique design idea that would benefit owners of vehicles who utilize it. This product is aimed to prevent the inside of a vehicle and items in the vehicle from rain damage. We wanted to create a tool that would help give the user peace of mind, so in case that they accidentally left their windows down and it begins to rain, they would not have to worry about it. The device would also be able to stop the window from closing if it detects a disturbance in the window's path. This is a safety precaution so that the window does not close and cause harm to anybody. Also, the original button used to roll the window down will be an override button. So if the user is in the vehicle at the time it begins to rain, they can stop the window from closing if they wish to do so.
With regards to commercialization, our design can be marketed as an additional add-on feature to vehicle packages, which will save the consumer's investment from weather-related damages and wear. Having an add-on that is self-protecting will give manufacturers an edge in the competition. As of now, vehicles are equipped with windshield wipers that automatically adjust when rain is present, but they are not equipped with rain sensing power windows. In terms of prototype quality and completeness, we have determined our prototype completeness to be 100%. The physical system is secured and encased within the door of the vehicle itself. And some issues that we are noticing is that the motor has already shown signs of fatigue. Some of the challenges faced throughout the development of this project include the current sensor along with the switch. In the beginning of our project, we were unaware how to connect the current sensor within the system, and once we connected it, it began damaging our components, which led us to the realization that we needed to include protective diodes to prevent back EMF. In terms of the original Windows switch, it was fully functioning in the beginning, but as the project came to an end, it had stopped working altogether. We had to take the switch apart, clean the debris that had accumulated, and position the buttons properly, which got it back to its original working state.
Here's a video of our project working. In this video, we first demonstrate the safety feature, which rolls the window down when an object is detected in the window's path. We also demonstrate the manual override switch, so even if the system is triggered, the manual override can stop the system's movements. And here's our software flow diagram. Basically, if the system detects rain, it will stop the window and begin to roll the window up. At this point, it checks whether or not a current spike is detected. If it is detected, it will stop the window. If it is not detected, it will continue to roll the window up.
So for the hardware block diagram, you can see most of the connections being made for our system. The bench battery, which is the power supply, is used to simulate a car battery to get the approximate power the system would be consuming if used in a vehicle door. The bench battery is needed to power most of our components, such as the relays, motor driver, the switch panel button, which is the override, and runs through the current sensor. The sensors are connected to the microcontroller, which is powered by the motor driver. But the motor driver is also getting digital inputs from the microcontroller to perform tasks such as rolling the window up or down. The power supply is connected to the button's connections on the outside of the door. The connections after the button are connected to the AC connections of the full wave bridge rectifier, which is then connected into the normally open connections of the relays used. The output of the rectifier is connected to the triggers of the relay, so that when the rectifier has power going through it, the rectifier triggers the relays and connects to the normally open pins and lets the override button take control. The normally connected pins of the relays are connected to the motor driver output pins. So when the relays aren't being triggered, the Rain Sensavior system has control. This is our poster. As you can see, it has the name of our system, the team members' names, and the name of the university we're attending. We have an introduction opening up to the problem, and then a portion discussing the problem with the need of our system. We list components and have pictures identifying them, attach both our hardware and software block diagrams. Then we go on to discuss our solution to this problem and a final conclusion, with acknowledgments and pictures of our group members. Thank you for attending this presentation. Are there any questions?